So as I mentioned, you can use any of these notation to declare a pointer variable. So, but most preferred way of declaring a pointer variable is the first one, and by using that notation, it will be easy you to understand and easily manage pointers. But most of people are using this one, second notation. But in sometimes you get confused when you are working with pointers. So that's the problem, right? And yeah, so before learning on pointers, we need to know about what is an address, right? So pointers are basically stores a particular memory address. Do you remember that when we are using uh, to get a user input uh, from the terminal or your command prompt, so we have used this scanf scanf function from the standard libraries. We have used this scanf function. But do you remember when we are using this scanf, uh, if we need to store something to a variable, let's say age, and we have declared say teacher, no, not age, yeah, right, age. Let's say it is a, and when we are storing, we need to mention as this, right, at a. So that means the value that we are reading should be stored in this particular variable, right? So that what that means is this at a represent a pointer to that particular variable, or that means the at a represent a address actually. So that address means a particular pointer to that memory location. So that means if this is the some chunk of your memory, and we have declared this is a, right? How? By using memory addresses. So there is uh, 16-bit notation. There is something like this, right? So this is a memory address, and if we call this memory or if we ask this store something, this memory address will going to address going to store something to here, right? And we are representing this chunk of memory location by the variable a. So when we are scanning, scan user input and put that to the corresponding variable, what we need is we need this memory address to pass that particular uh, information to the. So in there we are working with addresses. So pointers also used for that purpose. So in pointers we are storing only memory addresses. So here also a particular example. Uh, right. So we have declared a variable var which is initialized to 5, right? And we are here we are going to print that variable, right? So it will print in what? It will print number 5, right? And if we use this at, the symbol before printing. What will it going to print out? Anyone? එතනින් මොකක්ද print වෙන්නේ? Yeah, the memory address. Let's find out. Uh, so yeah, I will need to copy that code. Let's run this code and find out. Right? Did you see it's the variable value is 5 and is stored in this memory location, right? So this is the actually the address corresponding to that variable, right? So assigning address to pointers. So in this small code, so here we have declaring a pointer variable, which is in the type of integer. So this PC represent a particular pointer that will point to a integer value, right? So that means this PC holds a memory address, right? This PC holds a memory address, and it will point out to a particular memory location, right? Point to a particular memory location, and in that particular memory location have a particular integer value. So integer, as I may remember, it is 4 bytes, right? So this should be 4 bytes, 4 bits, 4 bytes. Sorry, should be 4 bytes, right? And now we are saying we are initializing this integer variable with the value 5, right? And the memory address of this C variable is initialized to this integer pointer. So what that means is we are declare and initialize a particular uh, integer variable, and its whole value 5, right? And we are mentioning that the corresponding address uh, of this seed variable will be equal to this PC. So what that means is initially, so I will do all this one. Initially, when we are declaring this variable, it don't have any value, right? It don't have any value. So no value will be there, right? But we aware, the compiler will aware this will be a particular pointer or particular memory location to a integer, right? And C also like this. C also not initializing, only declare here, and after that we are initializing it, right? When we are initializing, we know the value of C will be 5, right? And C has a particular memory location. Uh, that means is this is a memory. So this memory chunk will be represented as the variable C, and it holds the value 5, and there should be a memory address, right? Then we are assigning this pointer to the address of this memory location. That means this, so this will be equal to this PC, right? So PC is equal to this one, right? The corresponding memory location to the variable C, right? In that particular memory location, it's called the value 5, right? But that what happened there. So if you have any questions, please ask, uh, right? Otherwise, if you didn't understand any concept, please ask immediately. Uh, Even I am doing the tutorial session, right, students? So I am continue from here, right? So now we know how to initialize a particular pointer, right? And the next step is, if there are some value in that particular memory location, we need to get the output, or we need to print someone, or return from a function, or something that you need to do can be done by uh, get the that particular value out of the out of the function, or some step. So this is the way that can be done. So the first steps are here, and this PC variable. PC, actually the pointer variable has a corresponding address, and in that particular address has a value 5, right? And this is the way. So since this is an integer, this you will aware, this is the way to print a integer. And what we need to do is we need to call that particular value, right? So if we say simply PC here without this star, it will going to print out that particular pointer. So it should be in this way. So you need to use this P correctly print a particular memory address, right? But here now we are dealing to get output of the particular memory location. That means the value 5. So that means we need to dereference, right? So what that means is memory location is a particular reference uh, to a corresponding value. And the method dereference means by using the memory address. That means the reference, we need to dereference. That means get out the correct value, right? That's so when we are dealing with pointers, this star symbol here This star symbol is called as the dereference operator, right? So when you're doing arithmetic, this star will be used as the multiplication, and you may uh, seen there are many cases where you are using this star. But when you are working with pointers, this star will represent the dereference operator, right? You need to keep that in mind. Right? And since this PC is the memory location, we need to dereference this. We dereference it by using this star. So that what will happen here. So as mentioned here, the PC is the point, right? Not this star PC, right? So that means this PC is the pointer, not the star PC. So star PC, if the PC is the memory location, so star PC will represent the particular value, right? So you need to keep that in mind, right? So that's why actually when we are declaring a pointer variable, it's good to use in this notation, right? So otherwise we are going to confuse that if we use integer star PC when we are declaring, right? It is okay to use like that. That means integer, there's a small space and star PC. This is the semicolon, right? Star PC. This can be this is a correct declaring notation, but you can be get confused that this the whole symbol star PC is the actual the pointer name. This is wrong. The pointer name is the pointer variable is only the PC, and PC holds a memory location, and star PC is the value in that particular memory location, right? Uh, did you get understand that? So so when we are assigning, it is wrong to use this one. Star PC equals at C. So here also it mentioned this is wrong. You cannot use this notation. That means the star PC is the value, particular value is equal to a memory location. This is wrong, right? So only the PC is the memory address, and that memory address will be initialized with the memory address of this variable C, right? So please raise your hand if I need to explain it again, students. මේක ඔයාලට තේරුණා නේද මේ කොහොමද අපි value එකක් out කරගන්නේ කියලා pointers use කරලා? You can stop in anywhere and ask questions. So I need to explain it again, right? So simply, the PC is the pointer variable, not the star PC. And when you are declaring a pointer variable, you need to use this star. Otherwise, the compiler won't understand it is a pointer variable or not, right? And since this is a pointer variable, we can only store particular memory addresses. So C holds value 5. C is a variable, integer variable, and the memory location will be uh, can be accessed by this at symbol at C, right? So when we are printing, we can use this percentage D and C or star PC. So star PC is the dereferencing. That means when we are using star PC, it will call the particular value inside that memory location, right? We should get an error since at PC is right at PC. So that means so someone asks if we call at PC, what will happen, right? So at PC should be another memory address to this pointer variable, right? You get that point. So what that means is there uh, there are double pointers. So yeah, at the end of the today's session, we have that part as well, I guess. So if you use at PC, then that means the particular memory address to that particular PC, right? So what that means is PC holds a particular memory address. PC holds a particular memory address, and uh, this value, this PC, where does this? So it should have a another pointer to say this is PC, right? Can a PC PC කියන එක ඒකත් තව තැනක ස්ටෝර් වෙලා තියෙන්න ඕන. Yeah, I think you will probably uh, get more insight to this. So currently, uh, yeah, without going to uh, many confusions, uh, for at the moment, PC holds a particular memory location, right? So the particular memory location. So in that particular memory location, there are some variable, and we can get the that particular memory that particular value stored in that particular memory location by calling this one. So what he asks is, if we use at PC, what will happen? So what happened is it will print out. So that means all right. So this is the way we are print out a particular memory address, right? So this here let's assume, so we have initial declaring a pointer variable p, and p is equal to this at wow, right? What that means is uh, this p has the value for that particular memory address. This memory address of wow, right? And now the at var will print this p, right? At var will print this p, and what will happen if we print at p? That what Kalara asked, right? So what that means is to store this particular memory address. Store the P has, let's say, 0. This means this is 16 bits. Say it is 0001. So this value should be stored inside the memory again, right? So that means this P has another memory, should have another memory address to store that this particular value, right? It's some may something like say 1 0 0. So what that means is this particular memory address, all this P, and it has the value of this one, right? So it will print out this one. Actually, we can do it here. Hmm. Just copy. It's equals to wow. So right. So let's check this out. Right. The value of that variable is 5, and we are printing this var, and it's all this particular memory address, right? That means this var will represent this starting from this memory address. So since it is integer, the next 4 bits is for this particular to represent this value 5, right? So here we are initialize the pointer variable also to this memory address, right? So it also has the same, right? You can see the P and ATOA both are same. And the address of this P is something different, right? There is small difference here. And if you need to print the particular value again, so what we need to do is need to dereference it. And since it is D, should be something like this. Let's check it out, right? So the same value 5 will uh, print out here as well. So I think you have clearly understand that point, right? Okay. So next thing, changing the value pointed by the pointers. So let's do that one as So here I have initialized the var to 5. Now I am changing this var to 1. So then what will happen? You can see uh, uh, previous. So we'll do this one as well. Sorry, this is not address. Actually, it should be value. And the var, variable has the value 5. And here I am assigning the address of var to this pointer variable p. And I am printing both pointer variable and the var. And both have the value 5. And here I'm changing that particular value only here, right? And you can see when I print the pointer variable again here, the value of pointer variable again here, it also contains that particular value 1, right? So that means when we are changing the that memory, the value of that memory location, not the memory locations. That means memory location is same, but the inside value we can change. And when we are addressing that or referencing that particular memory location, so it has the same address, but the content is changed in here. So uh, so after that we are printing the same. Uh, it requires it will call that change variable. So that's why uh, in the runtime also change the value here, right? So what that means is, so the particular point. So it is, this is the or the, let's say simply C. So this has a particular memory address. We are not going to change this one. First it has 5, right? So next we are changing it into 1, right? But we are not going to change the memory address. And when we are calling it, it will print out the real-time value that is have in that particular memory address. So when you are printing here, it has the value 5. When you are printing here, it has the change value 1. That what happened. So in this example, what are the values? Please put them into the chat. 1 and 1. Yeah. So initially we have initialized to value 5, and PC the variable point variable has the that C's memory address, and now we are changing the particular value inside the PC to 1. So it should output value 1 in both PC and C as well, right? So shall we do it in here as well? So what that means is we need to dereference it, right? Let's check it out. And here let's print the value C, not C, it should be wow. right? You can see that the var value will change to 1. So even we can change the value by using the pointer as well. So I think you can go through with this example. So here also something the same. Initially it is initialized to 22. We are printing both, and we have initialized the pointer variable to the address of variable C, and here we are printing the address, and here we are printing the value. So value should be 22. If you change that one, it should print that particular value. And after that also, uh, changing the uh, uh, by dereferencing also, uh, we are changing the value, but the memory address is same, right? So these are some of the common mistakes that you will do. So please avoid these mistakes, right? So as I mentioned earlier, it is not good to use this type of. It is okay, but do not use this kind of notation to uh, declare a pointer variable. In that case, that you are going to get do those most mistakes. So here, so PC is actually the pointer variable should have a memory address, but C is a variable, and if you are calling in this way, it's called the particular value, right? So this is wrong. So here we have dereference. That means this one has the value. So that means we are going to change the particular memory location. So if you are using this notation, that is memory address, is also wrong, right? So correct way is to uh, either this at C, or using star. Then that means we need to call the value, right? So this is the correct way. So these are the correct ways. That means both at C and PC are addresses, and C and D reference PC are values. So please find out what are the mistakes happen here, and put them into the chat. Elisha mentioned P is equal at C. Uh, can you please put this whole code, type this whole code into a compiler and see are there any error? So please raise your hand if you couldn't find out any error here. error එකක් මෙතන හම්බුනේ නැත්නම් කම්පයිලර් එකකට දාලා run කරලා බලලා බැලුවා නම් පොඩ්ඩක් අත උස්සන්න බලන්න. කාටවත් හම්බුනේ නැද්ද error එකක්? මම තව විනාඩි 5ක් දෙන්නම් බලන්න try කරන්න. Space before star mark. You mentioned this one. So what should be the answer? As I think it's met the gay, right? What should be the answer? So is this one? Int star is this one? Integer star space p equals at c. And there should be a semicolon also. Or do we need to ignore this whole thing after the after phi or the after the pointer? Yeah, Vikramasinghe told me no error found. Output is 5. So let's find out. So we are running this code and forgot to save it. So save it and run. Yeah, we got the value 5. So that means the this pointer variable is initialized to the address of the CS file from here, right? So actually this code is there are no error in this code, but there is a confusion. That's why I told you the last few slides also. So try to use this, stick with this initializing, not initialize, actually declare it, and you may know we can even initialize particular variable, even pointer variable also in the first line, right? So this is the way you can done this. So here we are initializing the pointer variable t, and it has the value. Now we are going to initialize to the this variable, uh, the C address of this variable, right? So in previous slides, I mentioned that star P is showing the value, right? But since this is actually declaring, in declaring we need to show the compiler this P is not a particular variable like an integer or something. It is a pointer variable, and it has the value of that value of the, it not the value, it has the address of the variable C. So this is the variable, right? So that means there are no any error, but the mistake is when declaring, we in our eye we are got can we get bit confused if you are use this notation, right? So please, I think it better to avoid that, right? Mm-hmm. Yes, do right. So if you have any questions, please ask in the middle. So you may know when you are working with arrays also, the uh, the array name, it also contain a particular memory address, right? So as you are aware, arrays is a block of sequential data, and if we need to print a particular address, so this is the way. So let's run this code and find out. So here what we are doing is uh, we are going to print out that each of memory locations. I think you can see the screen. Yeah. Save and so the zeroth index has in this value 0C and 10, 14, and 18. So did you see that the first here we are going to print the address of the array X. That means the X value. What is the address of this X value? And it is this one. And the zeroth index. So here the zeroth index has this in this memory location, right? So that means both are same. That means the initial memory address is represented in the zero index, and uh, the corresponding uh, initial step of the array as well. So array X, the X symbol also represent the zeroth index memory location. That why both are same. And the next memory address, that means the index one, has this one. So you can see only four uh, bytes are different here. So C, uh, so C, after that D, E, F, after the F we get 0. So it is in a 16-bit uh, hexadecimal points. So hexadecimal points are have 0 to F, right? 0, 1, 2, 3, up to 9. So 10 will represent it A, 11B, 12C, 14D, 15E, and 10 10A, 11B, 12C, 13D, 14E, and 15F, right? So 0 up to 15. So 10 to 15 will represent it in the by using the English letters. So English alphabet, right? So C, there after 4 bytes we can get 0. After 4 bytes we get 4, 8 likewise. So that means the array uh, is a sequential block. So those data has in sequentially, and the starting address is the same address of the array name, right? So here uh, we are declaring uh, uh, 6 uh, size of 6 array. Name is X. So it has integer values. From here we are going to enter 6 numbers, right? So consider those are these one, 2, 3, 4, 4, 12, 4, right? And to calculate the sum, what we can do is uh, uh, so the x plus I. So so x plus first 0, then 1, 2, 3, 4, 5, right? So here we are going to calculate the sum, right? Hmm. So initially, uh, let's say here we are entering 2, right? So in this memory address, x plus 0 has the memory in that memory address have uh, this this value 2, right? Then so in using star symbol we are going to access this that particular value, right? So what happened next is, so we are going to add uh, another one. So x plus 1, right? So x plus 1 uh, memory address will have the next value, that is 3, right? So so likewise we can add elements to a array as well by using this notation, by using the pointers. So what that means is x has the corresponding memory address to that particular array, and since it is array, it is sequential. So next memory location will be adjacent, and since it is integers in this example, so integer has a size of 4 bytes, and the next memory address will have uh, after the 4 bytes. So in this way, we can actually traverse with the arrays also, and so I will do that how to uh, add more elements to the array up. That means array is a fixed size. So we need to change the size as well in the middle of our code when it is required. So we can even do that part as well by using these pointers and memory allocations. Yeah, since we have some limited time, so I will go through. You can ask question in the middle, even put them into the chat. Right. So consider this example. So here we have declared and initialized our array. Here. So it has 1, 2, 3, 4, 5. And we are initializing the pointer array as well. Not the pointer array, particular pointer PTR. And now we are going to assign this PTR to the actually the second element. So that what that means is 0, 1, 2. This is the 0th index, 1 and 2. So uh, so this PTR will have this memory address. So in that memory address, it has the value 3, right? So here we are going to print that one. So it has the value 3, and we can increment that one as it. So by using this increment by 1, right? What that means is it will increment the size 1 size of the integer, right? So that means it will going to go to the next memory location. So it will print the value 4, and we can go back as well, right? So in this way, that means we are now reducing. So by reducing, we can go back to this one as well. So next week I will do data structures. So in that tutorial session, you will need to do this one, right? That means you have an array. So this will help you to not only in the data structures by when you are doing algorithm to sorting. So there are so much algorithm are there that will need to use these pointers, right? So we can find out the middle of a particular array. So we are going to put a pointer there, and by using pointer, we can go both this, even to the front or the end. So that's something we can do by using the pointers. So it will help you to solve many algorithms and many problems. So actually, it should not C pass in C. So it is, please remove the C. So this is about pass addresses and pointers. So uh, when you are dealing with functions, as I mentioned previously, you can pass this memory address to functions as well by using basic way of passing variables at using at symbol or by using pointers. You can do uh, them in inside the functions as well. So there is an example. So when you are dealing with functions, also try to stick with this notation, right? Integer star means the upcoming variable represent a particular memory address. So N1 and N2 are memory addresses, and so this is the prototype, and this is the function declaration. So what that means, we are declaring another integer temp, and temp has the value of this N1 memory address, and now we are changing the value of that memory address to the N2 value, and uh, N2 value is changed to this temp. So what that means is temp will have the previous value, let's say 5. So let's say this N1 and N2 hold 5 and 2. This N1 and N2 hold 5 and 2. And temp is equals to 5. And N1 is now equals to N2 is 2. So N1 is 2 and N2 will equals to temp is 5. Right. Now N1 and N2 has the value 2 and 5. 2 and 4. So that means the swap happened. Not the N1 and N2, the memory location of N1 and N2, right? So you need to keep that aware. So what happened is number 1 is 5, number 2 is 10. Now we are going to change, swap them, right? So then, uh, right, we are swapping them here. So you need to keep aware. So this particular function will not going to return anything because it is a void, right? So I'm asking, please write a code without using uh, the pointers, that is the pointers or any return value. You can't return anything. What you need to do is swap two values by using a function. So function should be void, and here you need to put the values, let's say integer a and integer b, and you need to swap through here, but you can't return anything here. So when you are calling that function, you need to swap them and try to print the answers. Do you get that one correctly? ඒ කියන්නේ මම කියන්නේ දැන් මෙතන මම කෝඩ් එක දීලා තියෙනවා N1 N2 කියන memory addresses පාවිච්චි කරලා මොකක් හරි values දෙකක් swap කරගන්න. කියන්නේ variable දෙකේ value දෙක swap කරගන්න. මම කියන්නේ pointers පාවිච්චි කරන්නේ නැතුව මේ මෙහෙම function void function එකකින් කියන්නේ return කරන්නේ නැතුව value එකක් swap කරන්න බලන්න. කාට හරි පුළුවන් වුණාද සැප් කරගන්න? Let's try it out then. So this is the code, right? So what I asked was what I mean is we need to call this function and then we are need to print this value. It should we'll need to print uh, the after the SAP. So that means if 5 and 10, they should print 10 and 5. So in void SAP N1 and 2, and we are sapping them here. So this also same, right? So let's check this is working or not. So after that also it will print number one is 5 and number two is 10. Let's put a print here. Printf with this. Let it be easy. Number one should print this N1. Now let's check. So before SAP, num1 is 5, num2 is 10, and mm, and Stefan here. Uh, so before SAP, num1 is 5, num2 is 10. Num1 is 5, num2 is 10. Yeah, this should. And here we are swapping. So in the inside of the function, we are swap num1 into 10 and num2 into 5, right? So these now num1 and num2 are uh, 10 and 5. So after this function, what will happen was there are no any change, right? Num1 is 5 also, num2 also 10. That means even that let's even that we call these values to here, right? It not going to do any swapping actually, only showing us an illusion here. It is swap, right? So what that means is, so I will explain those when you are doing structures. So today, if you have a bit time, I will do that part as well. So in this integer main function, it only contains these values num1, num2, right? Here, what we are passing is only the values, right? So uh, when we are passing the value, it has separate, or that means it will use separate memory location to do these tasks. Not going to use the same memory location. That means this n1 will assign with this the value 5, and n2 will assign this value 10, and they are in a different memory location, right? Just give me a minute. They are in a different memory location, and in that memory location, the swapping is happen. So actually, these n1 and n2 variables are belong to this one. And even if we change this one to num1 and num2, this in this code chunk, these variables are belongs on only to here. But if you are passing memory addresses, those are have that exact value. So let's copy that code. So this was the previous code, right? So what will happen is, now we are passing, instead of values, we are passing the memory address, right? So that means in that corresponding memory address, the swapping is happen. Let's run this. I'm sorry, I forgot to say. You can see, right? Num1 and num2 have changed, right? That means here num1 is 5, num2 is 10, but we are passing that corresponding memory address. Now we are dealing with memory address, and we are assigning this temp to the value of that memory address n1. So n1 memory address is the where the number 5 is stored. N2 memory address is the where that the number 10 is stored, right? And using this temporary variable, we are changing the uh, uh, values that are stored in each memory addresses, right? So in this way, we are here changing the values inside that particular memory address, not in some another memory location. Exact, we are changing the values in the exact memory location. So that's how we are going to set for. So the we can do only by using the default integer functions and all, but in there we need to return that value as well to here. Otherwise, there will be no way to do this coding, something like this. So what that means is, by using pointers, we can easily do our tasks even inside the memory. And since we are addressing particular memory, so this should be carefully need to use. Otherwise, like there can be many bugs even some security threat also can happen. Uh, so you will learn those in next uh, programming lectures, or even in the second semester or third semester, where you need to maintain that hierarchy of coding to securely store these values inside the memory. That means if there are code something like this, and it is available to public, so they can easily change any variable, right? So we need to avoid that one. We cannot the normal users should not be able to access those memory locations. So we need to wrap them and only show the particular value, right? So I think you can go through with this one. So as mentioned here, you can do uh, arithmetic operation for point variable as. So here it has this value, and we can even uh, uh, do any arithmetic operations as well. So up to now, if you have any questions, you can ask. Okay, I will continue. So as I mentioned, so array is a collection of fixed number of values, and once we have declared, we cannot change that size of array. But if we need to change in if there are something happen, or if the declared size is insufficient, uh, we need to have some kind of method to reallocate. So we can do them that by manually by using this dynamic memory allocation, and there are a few functions that are available on stdlib uh, header file. So those are malloc, calloc, realloc, and free. So I will explain each them. So usually you will need malloc and free through our lectures. So in malloc, so malloc is memory allocation. So using malloc, you can reserve, or you can uh, allocate some block of memory uh, which is specified to a number of bytes, and when you are allocating, it will return a pointer to the starting, or pointer to that memory address, or the that block of memory, and the type will be void. So as here mentioned, the type will be void, and it can be cast to any pointer form. So this is the notation. So if so, this PTR should be a pointer. So here we are allocating memory alloc. Uh, we need to specify the size, right? And it will this function will return memory address to that uh, reserved, so allocated memory address, and we can cast into any type. So that means if we have allocate the memory of a size of integer, that means 4 bytes. So here it is, let's say 4, and if we cast to integer, so it will be same as declaring a pointer variable by using integer star point. So this both will be equivalent. So this is example. So here I am allocating 100 of size of float. So size of float will pass the actual size of float in byte, and I have multiplied it to 100. So hundreds of floats should be able to uh, allocate inside this point. So the float has 4 bytes. So 400 bytes of memory are allocated here. Size of float is 4 bytes. So the pointer PTR, this pointer PTR will hold the address of the first byte. So initial byte, uh, the address of the initial byte will allocate it to this pointer variable. And if there are occasions where we cannot allocate the memory, so then we will get this null pointer. Null pointer, that means there are no any memory left to allocate that size of memory. Right? So when you are coding, you will get those uh, these errors as a null pointer expression. Likewise, yeah, when you are doing data structures also, so there you will probably use many times this malloc and uh, free functions. So calloc. So here, what will happen is it will only allocate that part of memory, but in calloc it uh, will call initialize that part into all zeros. So in here the allocation will happen with the garbage data also there, but here the whole chunk of memory will reinitialize to zeros. So it is the same way of allocating the memory. So this is the way the you can cast into any type calloc, and you need to mention the number also and the size. So here, so this calloc uh, has a size of float up to 25 uh, contiguous space in the memory. So the 25 elements of floats can be uh, initialized or can be represent uh, in this chunk of memory, and this PTR will be hold the initial memory address, right? So since we are allocating memory manually uh, in using free malloc and calloc, uh, we need to free that memory as well. So what that means is, if we are allocated that memory, we cannot actually we need to free them. Otherwise, there will be garbage data inside the memory. So that's why it's mentioned you need to explicitly free the or release the allocated memory. So what you can do is by using the this free function, and you need to pass the that return pointer to that this function. So it will going to free up that memory. So here it is a example. So we need to standard input and output header and standard lib also to do this memory allocation. And we have uh, declaring a integer ni and a pointer variable ptr sum is equal to 0. This is declare and initialize. So this holds the number of elements. So by using malloc, we are uh, going to allocate integer size of integer memory with the given number, and it will hold this ptr uh, pointer variable. So if this pointer variable will have the null pointer, so that means there was a memory uh, out of memory or something problem when we are allocating memory. So we need to exclude that error. So if doesn't happen, then we can put our elements to our this allocated memory. So you can do this by using this. So we'll share the screen again. Right. So we were here, and so what this code will does is so currently we can uh, input three number of elements, and these are elements 100, 20, and 36. And after that, after we got our summation, we need to deallocate the memory. So what that means is we need to call this free function and pass this ptr point, this one, to here. So please go through with these codes and do the exercises and lab sheets. Then you can be more familiar with these pointer variables. So this is by using calloc and realloc. So if that previously allocated memory was not sufficient, we can use this realloc uh, to change the size. So please go through with this code, then you will have better idea. Yeah. So as I mentioned, you can do this point arithmetic functions by using the pointers as well. So uh, basically, uh, you need to aware that this uh, uh, some symbols. This star symbol also will represent that dereferencing, right? So in this particular case, uh, this integer a equals 1 and a plus plus means we are increasing the value. So a plus plus will be a b2 when we are dealing with pointers. So b plus plus, so pointer is in the type of integer. So it will increase the size of an integer. So what that means is 4 bytes. So here it will increment the size after the 4 bytes. That means 8008, right? So you can even increase, decrease also, and only the plus and minus operators. Increment and decrement operators are allowed, and even uh, the multiplication, division, those are actually meaningless when we are working with uh, pointers, right? So as I previously mentioned in the uh, beginning of the today's tutorial session, so I think Kalharo asked the question that what will given when we are uh, calling in the address of the point. So it has another address. So what that means is we can even use double pointers. So that means even itself is a variable. So that means we can use another pointer to pointer another point. That means there are a pointer A, and by using that pointer we can hold address of another point. So in that pointer also it has, since it is a pointer, it has another address likewise. So the initial address A will represent as this double point, right? So that means we are declaring a pointer P. So here I have used that wrong notation. It should be integer star space P and double pointer, double star P. And this PP will hold uh, the memory address of this. So in this example, uh, this is a double pointer, and and we are passing this memory address to here. So what that means is this function will return a pointer value. So this PP will hold uh, value that will have another pointer, and this P also will have another memory address. That's what. So this is another memory location. So P's value is holding in this one. So uh, it means PP. PP also, since it is a variable, it should need to have some kind of memory location. In this memory location, it has the address of that value P. So this P will hold another memory address to some variable or some chunk of the memory, right? That's what actually happened here. So you need to keep aware about these. So as I mentioned, pointer holds address of memory location. So uh, since we are dealing with the memory, we need to properly initialization and do our problem with very cautiously. Otherwise, it will go to crash the system as well. So what that means is this initialized point can we have a memory location where the operating system has put something protected uh, value or some that part of the memory should be protected, but we can actually able to access. So we need to carefully use this pointers when we are doing our problem solving codes or any codes when you are dealing. So what that means is when we are dereferencing, that means we are going to get the value of that protected chunk of code. Actually, since it is protected, so operating system will not going to allow to access that program or access that part of code inside the memory. So it will going to crash the program. So the fourth one. So in what there is an initialized point does not know the memory location it is pointing to is also valid value or some garbage. So what that means is even that the pointer is initialized, it will aware about that particular memory location. That means let's say 0x123 or something. It will know the particular memory location, but it don't aware what was there, what is in there, or is it garbage value, or we do not know whether it is valid value or not, right? It only knows the memory address. So you need to keep that in mind when you are dealing with some kind of a larger project. And even that the pointer cannot able to track boundaries of an array, right? So as you are aware, we can actually going to ask the uh, out of the array as well when we are working with C, and it will give the garbage values. So it is same as the pointer also. It will going to give that garbage value. That means it don't know doesn't know the boundary of a particular the corresponding array, right? So these are about pointers, and yeah, today today I will talk about some parts. Our next tutorial as well. Then tomorrow, next week, we can start data structures.